Good afternoon to everyone. And so before we meet our panel members, I'd just like to say a couple of words about smart buildings. That's the topic of our discussion today. The latest reports from the International Energy Agency suggest that the buildings and building construction sectors combined are responsible for 36% of global final energy consumption and nearly 40% of total direct and indirect CO2 emissions. The Efficient World Scenario Report projects that global building energy demand could decline between now and 2040, even though actual building floor space could grow by 60%. And the reason for this is because buildings in 2040 could be nearly 40% more energy efficient than they are today. Much of this is because buildings will be getting smarter by tracking what is going on inside the buildings and linking to the systems and electricity grid that supply energy to the buildings. Smart buildings are able to make continuous adjustments to increase the efficiency and reduce the cost of energy use. According to some recent market research reports, the global smart building market is expected to reach $36 billion by next year and $62 billion by 2024. Smart buildings are smart because some smart people know how to collect large amounts of data about energy consumption in the buildings and apply smart approaches such as machine learning and artificial intelligence to come up with the innovative solutions to optimize building energy performance. And three of those smart people are with us today. They are, sitting next to me here, Anthony Diamond, CTO and co-founder of Axiom Energy.
Exergy.
Exergy.
So it's a mouthful, but
oh no, I know
we have a technical community here, so maybe they'll know what that means.
Okay, I'm sorry. I know all about Exergy. And in the middle here is Matt Duesterberg, CEO of Ohmconnect. And at the end, Mark Chung, CEO and co-founder of Verdigris. And I welcome them to our discussions. So I wanted to start by having the panel members introduce themselves. And in their introductions, I'd like them to discuss the pathway that they took from their days as a student at Stanford to the current position that they're holding now. So maybe we'll start with you, Anthony, and then go to Matt and
Sure.
Mark.
Yeah, so my name is Anthony Diamond. I'm the CTO and co-founder of Axiom Exergy. My primary roles and responsibilities at the company right now are setting the product roadmap, managing our intellectual property portfolio, leading various product development initiatives, and managing relationships with strategic partners of a technical nature. So in terms of the trajectory to Axiom, I was here for an undergrad degree in mechanical engineering, and then did a co-term in material science. And while I was doing that undergrad mechanical engineering degree, I was looking at the types of projects that really seem to have or were going to have a large impact on the energy landscape. And I started to notice that most of the research, most of the work that was being done, even in the mechanical engineering department, was really focused on materials. So kind of midway through my mechanical engineering undergrad, I decided that material science was going to be really important for me, but I still wanted to learn how to manufacture things and make things. So did that, followed by a co-term in material science. And I guess I've been very interested in trying to make an impact in the energy space, trying to bring about kind of the renewable energy future that we're all kind of engaged with in some way. And wanted to figure out sort of an energy technology that I could help to commercialize. And so looking at, after the co-term, looking at what would be the best opportunities to do that, I determined that going into the PhD program at UC Berkeley is where I eventually ended up, was going to be the best opportunity for that. So I was able to kind of obtain an NSF grant as well as a Chancellor's Fellowship at UC Berkeley, and under the directory of Ramamuthri Ramesh, pursue the development of kind of next generation absorbent materials for photovoltaic applications. Ramesh was the first leader of the Sunshot Initiative, touted by Energy Secretary at the time, Stephen Chu. So, as I was progressing, as I was there in the program, something really interesting happened. So focused on, bringing down the cost of photovoltaics to price parity with fossil fuel generation. The cost of solar drastically came down, for a number of reasons that we may be familiar with, market forces just riding down the technology cost curve. And the cost was coming down to the extent that it became clear to me that, getting kind of the next best, cheapest solar panel wasn't really going to move the needle, and really I needed to look more further afield to what would be the big bottlenecks. And so at that point, I started to focus more on energy storage, how energy storage and solar generation could play synergistically with one another. And that kind of led to the separation of my entrepreneurial passions and what I eventually ended up commercializing with my co-founder and the PhD research. And so, the focused initially on energy storage with solar, realized that, especially in a post-2008 funding landscape, that having this massively complex system that would take $15 million to get to a prototype with was not going to be feasible. And so then kind of focused in on the energy storage aspect itself, and then recognized that, ultimately we didn't want to be beholden to just like one potential customer, like a utility. And so trying to find a behind the meter solution that would kind of ultimately enable us to gain traction with customers. There's more to talk there,
we'll
but
get to
yeah.
depth in that in a moment.
Thanks, Anthony. I'm Matt Duesterberg. I'm the CEO and co-founder of Ohmconnect. We're an energy sharing platform. We pay people to reduce their electricity 1 or 2 times a week. And like any good Silicon Valley startup, we have an app. So we just have an app that you download, and we send you a text message from, say, 7 to 8 p.m. tonight, save electricity. If you save electricity, we pay you in points, and that gets translated into cash via PayPal or prizes like trips to Disneyland or Target gift cards. So very simple concept, and we've grown tremendously over the past 5 years. We now have about 100 megawatts on the grid across about 500,000 users signed up in California. My trajectory to get here was actually before I came to Stanford. I went to undergrad at UVA, University of Virginia, and I studied chemical engineering with the hopes that the hydrogen economy would occur. I don't know if you guys remember back in 2000s. Everyone was talking about the hydrogen economy, and sure enough, that fell flat. So I went into chemical engineering at UVA, and then I ended up at a financial trading firm trading electricity on what they call locational marginal prices, so LMPs in the wholesale energy markets. It's a fairly novel type of marketplace that established in the early 2000s to better understand congestion in the wholesale energy markets. So I was very lucky to have deep knowledge of the LMP markets before I came to Stanford. I came to Stanford because while it was fun and lucrative, I actually wanted to make a difference. And so I went to Stanford for a year. I took this course and tried to learn as much as possible, and ended up in the utility sales side of the energy sector. So small company called Dataraker. It got bought by Oracle, same division that OPower is now in. But basically utility sales, and saying, here's a bunch of smart meter data that everyone has in their homes, and how can we leverage this data to be really powerful and insightful for what the future grid needs. Unfortunately, the utilities really didn't understand anything about data. And they really just wanted to know whether they were on or off. Literally, that's all they wanted to know, whether they were switched on or switched off. And so it was a little frustrating working in that environment, but I did learn that there's a tremendous wealth of data behind these smart meters that are being untapped. And that is really the core of what Ohmconnect leverages, is that we're able to say, have you reduced electricity? We can pay you for that. And it's really interesting if you look at our users that have smart meters and users that don't. The people that do not have smart meters have a terrible experience. Because we send them a text message, 7 to 8 p.m., reduce your electricity, and then after, we're like, good job. We don't know if you did anything, but good job. And if we have their smart meter data, we're like, actually, you didn't do anything. We're actually going to take points away. so there's a little bit of loss aversion. And then if they did something, they get rewarded. And that core loop of action that they take, getting rewarded, is really important because they want to know, and as we all do, if we do something, did we do it well? And if we just say, hey, you did a good job no matter what you did, that's actually pretty boring as a product. And a lot of our users in that sector attrit. And so one of the things we push is smart meters are good. Don't wear the tinfoil hats. They're OK. Use smart meters and get paid from Ohmconnect.
Cool. All right. I'm Mark Chung. I'm the CEO, co-founder of Verdigris. Let's see. We make an artificially intelligent energy management system for industrial facilities. It's about 10 times more efficient than anything else that's currently on the market. How did I get here? So I did my undergrad and grad degrees in electrical engineering and VLSI about 20 years ago at Stanford. And that was the big thing then to develop chips and microprocessors. So I went and did that for a very long period of time, first at a startup company called NextGen that was acquired by AMD. And we developed some really powerful processors, including the Opteron, which finally brought Intel to its knees. And then I decided to join Steve Jobs on an adventure to build a PowerPC that could do the same and bring Intel to its knees. And so we worked on a company called Palo Alto Semiconductor. And for a number of years, that company built really powerful microprocessors with a PowerPC architecture for MacBook. Eventually, Steve used that as a bargaining chip to get all the chips he ever wanted from Andy for free. And so that was the end of our company. And then, then I started another company with the guys who founded NextGen. It was a gentleman named Atiq Raza. It was called Raza Microelectronics. And then we went off to, we couldn't compete directly with Intel. We were building MIPS architectures, but we eventually found a niche in high-performance network microprocessors. Eventually, that company merged with NetLogic Microsystems. And we grew that company to about $4 billion before it was bought by Broadcom. And at that time, my co-founder and I were developing a really interesting technology for deep packet inspection. And that technology gave me the insight that we later used to develop the artificial intelligence behind Verdigris, which was that we could take a single stream of information and disaggregate that information and reverse engineer it to understand what was generating that information. And so we applied this to my house because I had a pool pump that had malfunctioned, but I couldn't find it. For a period of time, I had a $550 energy bill, but I couldn't figure out where it was coming from. So we eventually tracked it down with this technology to the pool pump. But along the way, I discovered that every single device in my house was generating a very unique signature that I could disaggregate and figure out. And that kind of sparked an idea that at some point this technology would be very useful for figuring out what's happening inside these large facilities if people cared about energy. And then we shelved that technology for a number of years until I had my own kids and realized I care about energy because it's gonna destroy the planet, and my kids are going to wonder what I was doing the whole time. So that's how I started this company. That's what we're working on.
Okay, thanks. So, Anthony, all of you all have different ways of trying to improve and optimize the consumption of energy in buildings. Do you want to sort of explain exactly? I know, Matt, you've already started on this, but Anthony, can you explain what you're trying to sell and what's the business model behind it that underlies it?
Yeah. So we provide savings as a service for. We are kind of the power management platform for the cold chain. And what we do, our offering right now is a product called the refrigeration battery, which kind of plugs into the central refrigeration system at a facility like a grocery store. We provide savings as a service as a completely kind of turnkey managed service. So we add this last piece of marginal hardware that's required to turn these facilities into cloud-connected, intelligent energy storage assets. And so, part of what we do is building and deploying those assets. And then kind of the other major aspect of our product solution is the cloud platform and intelligence behind how to operate these assets to maximize savings for our customers. And so we do this by trying to kind of first collecting data around the historical operation of that building, developing kind of an in-depth physics-based model of the refrigeration battery itself, so that we can abstract these thermal systems to essentially batteries, electrochemical batteries, or batteries with electricity in, electricity out. And so we kind of integrate those two together, and then use our various optimization frameworks to figure out how to most intelligently operate those assets.
Matt, do you want to add anything?
Sure. So I talked a little bit about what the consumers experience from Ohmconnect, and a lot of people ask, how do you actually pay the consumer? We get this actually a lot. They think we're a scam because they wonder, how do you pay me to reduce my electricity bill? And the reality is what we're trying to solve is the mismatch between supply and demand. And if you think about it, when you use electricity at home, you generally use in the morning when you wake up, and then you go to school or go to work, and then in the afternoon you spike your energy usage. And that's generally kind of the curve that California experiences. But let's take solar. Solar really just has electricity when the sun is shining, 7 a.m. to 6 p.m. We use electricity a lot of times outside of that solar time period. And this is causing a great strain on the grid, and I'm sure you guys are well aware of this, but it's surprising how little of the rest of the world outside of the energy sector is aware of it. What we do is we actually package our users' energy reductions as negawatts or new power, and then we sell it onto wholesale energy markets. So we actually have 500 resources in the California ISO. They're all very, very small power plants, about 0.2 to 0.5 megawatts each. And they're being bid on every day. And as soon as the energy grid needs half a megawatt here or half a megawatt here, we dispatch our users and say, hey, go reduce your electricity during that time. And we actually get paid from the energy markets as if we were a power plant. So if you're thinking about it from like an energy operator, they think, should I pay a gas power plant $300 to turn on electricity, or should I pay Ohmconnect $290 to reduce the same amount of electricity? And so that's kind of how the market works. When we get paid on the $290, we pass that money back to our consumers. So I'll pause there.
I love Matt's explanation. Super crystal clear and beautiful model. So what we do, we make an artificially intelligent clamp-on sensor. It goes into the electric panels of a building. It connects to a cloud where we have cloud software that manages all the electricity. We're diagnosing all the things that are going on in these large facilities. And then we provide a layer of transparency that can then be integrated into other kinds of systems, either building management systems, battery storage, or other kinds of systems. So we basically provide an artificially intelligent data layer for the building. We focus mainly on large industrial facilities. Some of our biggest customers are like a major retailer that's got massive online presence in the Northwest. And then another one of them is like a large OEM consumer electronics manufacturer. Some of our customers like us to not share too much information, and I don't know exactly how far this video goes, so I'll stop there.
Might have to edit later.
Yeah.
Okay, thanks, Mark. So you mentioned data, and that was what I wanted to ask next about. Is really data is at the heart of all three of the approaches that all three of you are taking. Can you tell us a little bit about the data analytic techniques that you've developed and the issues that you face as you try and apply them in your three different approaches? So maybe
Sure.
Anthony.
So we, what's interesting for us is that we are ultimately operating our energy storage asset and affecting the building such that the operation or the actual power from that building is different than what it would have otherwise been. And so it's important for us to be able to, with a high degree of reliability and kind of confidence, develop a building baseline that represents what the building would have been doing otherwise. And so there's a number of things that go into doing that. Understanding things like sensor uncertainty at a ground level. Understanding the quality of the data that you're going to be receiving. It's error bars, whether the general calibration techniques for collecting that information. Because I know it's kind of a tenet of data science, but garbage in, garbage out. So it's really important to first kind of determine the quality of the data that's going to be required for these models, and then understand that how manipulating that data introduces other potential sources of uncertainty. And so being able to map that uncertainty is key to being able to kind of get to a result that you have confidence around. And then on top of that, there's kind of your standard ML techniques and various optimization frameworks, convex optimization, to figure out kind of what is an optimal strategy, along those lines. But I guess one of the major aspects that I would kind of put forth is just like the how key data quality is.
Happy to jump in. I've got, data is one of the things that people can talk about for ages, but I'll just make 2 points. Sorry about that. I'll just make 2 points. We kind of have one side that's, I would say, really boring but required in terms of data access. And one of the challenges is that smart meter data is traditionally really hard to get. I mean, there's even a question on who owns the smart meter data. Is it the consumer who's actually using electricity, or is it the utility? And generally, there's a push for the consumer to own that data, but of course, the utilities would really like to own that themselves. And what we've seen in California, and the reason Ohmconnect can even exist, is that there were several policy changes, regulatory change, that allowed us to even access the data. Just without data, you can't do anything, but to even access the data was required laws to be changed. And that's really where we've invested a significant amount of time. We have a 30-person team, and 5 of them are on the policy side to really drive forward these new laws. And they're actually really, really boring, but really essential. And so I think, I had one piece of advice is don't overlook the policy sector as you leave Stanford. I think that's an area where you can enact great change very quickly in a short amount of time. And I'll give you one really short example of this. I'd say there's like a dark side of, I'd call renewable energy in the solar and storage space, where the way to get data for consumers is actually to get your utility credentials, your login and password. And so we're storing your username and password in a separate database and then logging on as you to extract that data. And that's existed across a large number of companies. In fact, companies have even been built to do that for you. And one of the things we pushed is say, whoa, this is a really bad practice. No one in other sectors ever does this. But we're doing this because the utilities are so slow to adopt. And the regulators in California force this, and they're leading the charge. Illinois and Maryland are close behind. But they said, okay, we're just going to do it like Facebook does, where a user can log into your site and say, hey, Facebook, do you want to send data to Ohmconnect? And Facebook says, yes. And then there's no passing credentials or anything. So this is called click-through, and it costs the utility $60 million to put in place, but it's in place now. So that's kind of the boring side, but it's absolutely essential to get that data and access that data in a streamlined fashion. And we're still having a lot of issues on that front. On the more fun side is where we've seen consumers. Are we taking questions now, or should we? Okay. Consumers various companies in the consumer space have looked at data in a way that the energy sector has never looked at. And so these are companies like Amazon, Google, Facebook, and they look at it from a transactional standpoint, where there's billions of experiments happening on the web daily. And so I'll just give you a quick example, is when you log onto our site at any given time, if you look at an incognito window for 2 different times on our website, you'll see maybe a different tagline or a different button, colors, anything that we see that we can change that tests whether consumers get engaged more. So there's literally dozens of experiments, and that's a really complex statistical infrastructure that you need to build to have experimentation happening at that rate. And so we have large experiments such as some users are receiving only prize ohm hours. They can only get trips to Disneyland, while other users are receiving paid ohm hours. They can get cash for those reductions. And there's even small experiments like, what's the color of the button? And all of those are overlapping and interweaved. And it allows us to make very clear product decisions that say, hey, I really feel passionate about, bring environment to the front. We want to be always talking about the environment. And my other team member is going to say, hey, I really think payment must be up front. Save energy, get paid should be our tagline. You don't have to have those arguments. You just have the test. You put one or the other, and you see which one has better conversion, and you take that. And that's a learning that we've had applied to the energy sector, and a big reason I think we've been able to attract the number of users we've had in such a short amount of time.
Mark, back to the data question.
Back to the data question. I mean, it's really interesting. Our model's not super complicated. We realized that smart meter data is really difficult to get. We also realized that all the other data sources on the market didn't provide the level of detail and granularity that we needed to perform the algorithms that we needed for our system. So we designed and built our own IoT device and our own sensor, which is a very high fidelity electric signal sample. And to Anthony's point, I think keeping that data signal very clean and perfect and credible is paramount for us. But that is the principal data source, which is our own proprietary data source. And it allows us to install much faster and cheaper and easier than any other system.
All right, thanks. So you've given us, all three of you have given us a very comprehensive description of your products, your services. What were some of the unexpected challenges you faced as you came to the point that you are now? I don't know who wants to take it first.
Me?
Sure. Let's go the other way this time.
Yeah, I think maybe keeping in line with the theme here, the unexpected challenges. I guess coming from a background where the markets were relatively well established, which is semiconductors, where you have a very clear target and you're dealing with very sophisticated customers to deploy your systems. Moving into the energy space and dealing with facilities management and building engineers and electricians and sometimes security people. I think there was a big difference in level of sophistication and a big difference in technology in the space that surprised me. It surprised me that there are very large incumbent businesses in this space that focus on a very small niche group, and they extract as much money as they can, and they just kind of sit there comfortably extracting a large amount of money. And that has never been the ethos inside a semiconductor industry. We just crush ourselves 18 months after 18 months after 18 months, just destroying the whole industry every time. So that was a pretty enlightening coming into this field.
I'll speak from first-time entrepreneur. Unlike Mark, I was just shocked at how hard it is. I mean, there is challenge after challenge that literally can sink your company. And I feel like there's been many times, half a dozen times, where I was like, I don't know if we're going to have a company next month, and it's so visceral and real. And it's hard. I mean, I think that's, as much as people say that you should expect that, it becomes your baby, and you're like, I don't want to throw the baby out.
Unexpected challenges. I think one of one of the main ones is just that you can't expect like a contractor or someone that's that's providing a service for you to necessarily deliver what they're advertising. So you need to like be extremely diligent about oversight, until at least the processes are developed that can kind of provide guarantee of the quality of their outputs. But it's been surprising how often various parties we've interacted with just need that additional level of oversight to provide kind of the advertised level of service.
Okay, thanks. So now we've overcome those challenges. Now we can look into the future. Mark, at Verdigris, you have devices. And as you look into the future, where do you see the big advances? Is it in the devices themselves? Is it in the amount of data you need, the algorithms that you need to handle that data? Is it in the computing power? Where do you see the advances as you look into the future?
That's a really good question. I think there's, the stack itself is complex along the whole dimensions. Certainly, I think there's going to be very, very fast advances happening on the AI side as we get more and more data access. And part of our company's strategy, without kind of giving it too far away, is to enable more partners within the ecosystem to have that kind of data quality that we can provide with our sensors to give us much more reach. Because I think that's going to ultimately enable a level of fidelity that will develop the algorithms. So I would say there's a lot more to go with the data that quality that we have. We can sort of see things that we can do in terms of predictive analytics on mechanical systems, safety systems. There's a lot of stuff in the data that we already have. That said, I think there's also some amount of innovation that's still to be done on the hardware in terms of cost and ease and accessibility. And I think just again bringing that semiconductor mindset, we want to make that system so inexpensive and so easily accessible that it would literally be something in every single home or every single building in the world. So there would be no barrier essentially for having this data source coming through. So there's a lot to be done on the magnetics, the connectivity, the wireless charging, all the other pieces of that physical component.
Okay, all right, thanks. So Matt, you've alluded to how you're dealing with utilities and the regulatory environment that you need to work in and address. Where do you see, as you look into the future, where do you want the regulatory environment and policy environment to move to help your business model succeed?
The short answer is to catch up to California. I mean, I think what we've seen in California over the past few years has been excellent. I mean, the solar penetration is really making 100% renewables a feasible place to be in 20 years. I mean, I think if we look back 20 years ago, we would have been like, no way. There's no way we could get fully off fossil fuels. But there is some major challenges still ahead. But the fact that it's a mandate, SB 100 in September, was just amazing. I think that is kind of one element. And it's really hard to look around to the rest of the states and see how other models have worked. I mean, if you look at New York with the whole REV proceeding, I don't know if you guys are familiar, but reforming the energy vision has been a theme in New York over the past few years to really work with utilities to get them to play ball and really encourage innovation to occur. Whereas I think California has taken a different approach, which is really the more stick mentality of like, you're going to do this. We're going to mandate it, and you're going to do this. And that has really encouraged more companies to create innovation. So I think the regulatory model in California, hopefully with Governor Newsom, we see Senator Stern said at one point that Governor Newsom is more of a climate advocate than Jerry Brown, which I don't know if that's even possible, but that would be fantastic. So that's the hope.
Okay, great. Anthony, in your case, you have your refrigeration battery. You have customers who are cold storage facilities, supermarkets, and so on. How do you see in the future where the customer base is going to broaden out? It's probably going to go beyond that. in the future?
Yeah, so we believe that we kind of hold the seminal IP for the economic inclusion of energy storage in direct expansion cooling systems. And these DX systems, though they form the basis of refrigeration, they also comprise about 25% of the global HVAC market in the form of like VRF, variable refrigerant flow systems. The IEA released a kind of a report in May of last year that highlighted the fact that the usage of HVAC is expected to triple by 2050, which basically would require the energy capacity of the United States, Europe, and Japan combined just to provide for this additional HVAC capability that will be coming online. And so we see that as kind of a natural extension probably of what we're doing. And the vision is really to turn these kind of dumb cooling systems into flexible, intelligent, cloud-connected systems. And so I think that really provides an immense opportunity to expand the capacity of energy storage to be able to handle a much deeper integration with intermittent renewables on a larger scale globally.
Okay. All right, great. Okay, well, I think I'll stop with my questions now, and I'll open it up to the audience for a few minutes, and we go first to students, and then to everybody else. So maybe over there, yes, your question.
Hey, thanks for your time, guys. Matt, question for you. So how adaptable are you seeing that consumer behavior really is? Like, I understand the insights, but are people at scale, can people really change their consumer behavior enough? Or are you seeing challenges with that?
I think, first of all, it's bigger than we expect. I'll give you just one stat. Our average max reduction from our users across their best ohm hour is 78% of their load is reduced. So there's a tremendous amount of capture value that could happen. Now, these are highly incentivized events, so there's some caveats around that, but 78% is deep. But I think that no matter what, we need to move to an automated environment. And that's where we see most of our users retain. Like, we have much better retention, much better engagement with users who have automated devices. And I envision a world where, each of the appliances you buy, say it's a TV, a refrigerator, a laundry, what is laundry? Washer and dryer. All of those should be smart connected. I mean, they often have Wi-Fi chips enabled, but not a single one of them are connected directly to grid, and that's ludicrous to me. Like, why don't we just have them connected? Because most people don't really care if their laundry is done from 11 to 12 p.m. or 4 to 5 p.m. It's like I want it done during the day when I'm gone. And I want it to be ready when I get home. It doesn't really matter. And so I think automation will be the key to make that truly deep and truly reliable.
Okay. Yes, over there.
So I didn't get the point where you just download your app, you essentially push like you normally do with Facebook, I want this stuff, okay, and you get all the data. That's it?
It is now, as of 2018 in April. Yeah, that's click-through, so. This is only in California, the IOUs, the investor-owned utilities. Hopefully it will happen nationwide. So.
Yes, over there.
Thank you so much for your time. You had mentioned that you would like to install smart meters in every single home and reduce the hardware costs. But this is for electricity. How about gas and water meters and other meters across the United States?
Yeah, so not necessarily smart meters, because I think there's a big infrastructure for that. I think we're talking about behind the meter in the panel. But I would say electricity is where we're focused, because that is the largest contributor to the problem that we're trying to address, which is the carbon component of it. There's a lot of companies out there that are moving to electrify all other sources of energy. Because of its easy transmission, portability, distribution, generation, renewables, all the reasons why gas, I think, is nice, but it's not a complex technology to put a flow meter on a gas rate. I think the similar thing could be true for water. There's a lot more unique applications for water, but there's, again, a limited market for what we would want to focus on. So we are looking at partners that are in the ecosystem that may be developing that kind of technology and bringing them into the fold of our AI. Hope that answered the question.
Okay, I think we'll go ahead. Yes.
Okay. Two things. Anthony, do you know about cool expert technology working with the cool expert system to say basically advise what's going on in that system using AI in the market? And are you looking at storage?
Energy storage?
Not so much. So I'll check it out.
Yeah. Yeah, for energy storage, yes, we are. We have a partnership with a company that does battery storage in Korea. They manufacture systems. They're cloud connected. We've developed application notes with our forecasting engine and our AI controlling their systems. We can produce very, very efficient building connected battery systems. They outperform other comparable systems in the marketplace. I think we're letting our partners sort of drive that initiative while we focus on certain data accessibility issues right now.
I'm on.
Can I ask two questions?
Maybe. Since you're my boss, I'll let you ask two.
Question one. You talked about technology, which is obviously the focus of that. Can you say something on the business model innovation that you have to do to make money? That's number one. Question number two is, we just learned that the United States emissions went up by 3.4%. And if you look under the hood, this is 2018. If you look under the hood, it basically says, despite all the integration of wind and solar and decarbonization from coal to gas, the demand increase was so much that solar and wind couldn't keep up. Given that you are in the industrial sector, you are in the residential, and you are in the small business and small enterprise, you're looking at all the load profiles that you're seeing. Where is the lowest hanging fruit that you can go after to reduce the total demand? Not so much shift it, which is what storage is doing, but reduce the total demand over time, over an annual period. So two questions. One on business model. The second is on sort of how do you reduce demand totally?
I can start on the business model one. So I think, before Ohmconnect existed, and we really are riding the coattails of California regulators, there was actually no way to sell, as a third party, sell megawatts directly back into the market or negawatts directly back in the market. You always had to go through a utility. And part of the business model innovation is really to open up the floodgates to allow third parties, such as Ohmconnect, which we're one of the leaders, to access those markets directly. And instead of having a kind of siloed PG&E or SCE can participate, it's now anyone can participate. And that's really where we've seen innovation occur on our side.
Yeah, I would say I'm kind of echoing that. Matt, I think, has a pretty unique, interesting business model that is innovative. For us, we do have our own ideas around the direct and indirect network effects of more people in our ecosystem that I think we have some innovation to do downstream. Currently, it's a very straightforward SaaS model. So I think the basic innovation for us is reduce the capital cost, get people out of the sense of like a barrier to entry into the market, and deliver the benefits more immediately so that it makes the sales process more friction-free. So that's kind of how we approach it, and we're focused on a market that already exists with a large amount of capital so that we don't have to do too much there. But I think as we penetrate further into mid-markets and others, there are partnership strategies that we're working out with particular OEMs that would enable us to do some innovative things on a software basis or licensing models. And then there's interesting things that we can do when people are participating in our network that we can do, hopefully at some point, transact across. So I won't. Yeah, there's a lot of opportunity for revenue generation and multiple streams of revenue generation for the data.
From the perspective of total energy reduction, I think that is definitely tricky. I think there are opportunities with the kind of synergies between different systems in buildings. So, like a refrigeration system, for example, a lot of times the waste heat is reclaimed and used for other purposes in the building. And so I think some of it could come from those sorts of crosstalk between building systems. In terms of business model innovations, we took a really deliberate approach to kind of copy everything else from a business model perspective that other providers of energy storage were doing to kind of make it really simple and approachable for our customer base. The real innovation, I think, from that perspective was really diving into the pain point. And so identifying what really moves the needle for customers. It's great to provide services, in this space and be directed toward trying to move us toward a renewable future, but that has to be balanced, with what is the customer going to get out of bed for in terms of the actual service that's provided. And so our initial focus is our supermarkets, and supermarkets are a large volume, low margin business. And so being able to provide a healthy chunk of savings really moves the needles for these customers. So that's something that I would definitely kind of provide as what we did, but also as general feedback for people looking to find market solutions in this space. It should be driven by. It's great to have technological innovations, but it's really, at the end of the day, going to be driven by customer need and the customer pain points.
On the residential side, I think it's just education. Our users have no idea where their energy is going. And we have a user who had a bill for $2,000 a month. And when they had an ohm hour, they're like, yeah, I turned off all the lights and I'm sitting in the dark. And they had their washing machine going, and they had their AC going, and they're like, yeah, it's like, I'm totally doing it. And they're like, no. The washing machine is way bigger than those lights that you're already at, CFL. So it's education, but that's hard. How do you get into the homes of 99% of the population?
Yeah. For the industrial, I would say there's a lot of lost efficiency in the machines. So the way processes are operating, for example, certain heat elements or heating elements that are cooking processes, they may be compounded in that they're all heating up at the same time, which could be triggering demand. But even the flow rates through and the managing of calibrating these machines or turning them off or turning them on, those kinds of pieces of information are missing. So they can't make those adjustments. Also, a lot of mechanical systems. There's something like 60% of the electrical load being pushed through motors and pumps, and those types of equipment generally have been failing much more frequently, or causing these small failures that you won't see manifested in a failing system, but just in a slightly increased energy bill and a slightly gradually increased energy inefficiency. And over time, it cascades. So there's a lot of those kinds of unknown problems lurking.
Okay, I see the time. I'm afraid we have to wrap up now. But can you please join me in thanking our three panelists for coming back to Stanford and sharing all the information? Thank you. Fascinating discussion.